Lesson 11 is solving inequalities. We're going to talk about how to solve one-step multiplying and dividing inequalities. How do we cancel multiplying and dividing? We do the opposite just like we have for solving equations. The goal still is to get the variable by itself. This is a huge note. Can't stress it enough. If the coefficient is negative, meaning that when you solve it you multiply or divide by a negative number, you must switch the inequality symbol. So if it was less than, we're going to switch it to greater than and vice versa. So for question number 1, we're going to do the opposite. So we're going to divide by 4 on both sides because that says 4 times x. X is greater than 3. We use the same little piece of the number line we need. It's an open circle because it's not equal to it, and it goes to the right. Question 2, notice that negative right there. When we go to solve this, we're going to multiply by negative 6. Anytime we multiply or divide by a negative number, we must flip the symbol. So the symbol was, if you notice right here, it was greater than. When we do this answer, we switch it to the opposite, and now it's less than. Again, notice greater than here, it now becomes less than because we multiplied by a negative number. We use that little piece of the number line we need. Open circle, less than goes to the left. I'm going to move this up here. Number 3, to solve this, we're going to divide by negative 5. And remember, it's a negative. So we switch the symbol to the opposite, which is greater than, negative 2, and we solve for it. So remembering this little rule will ensure that you get a good score in the next test. Negative 2 circled open, going to the right. Number 4, I do not switch this one because it's not a negative number. So I multiply both sides by 3, do the opposite. So x is less than 45. Make the part of the number line that we need. Open circle, less than goes to the left. Number 5, a little confusing for some people, but I divide by 6, not negative 6, so I don't flip the symbol. This over here is negative, but it's not the coefficient. The coefficient is the number in front of the variable. So this stays. M is greater than negative 11. Open circle, greater than goes to the right. Number 6, divide both sides by 4. C is not equal to 5. 5 gets circled and it's open because it can't be equal to it, and it goes both ways. Let me move the screen up here, do the last couple problems. This one, I'm going to multiply both sides by negative 3. Remember, when I do that, it's a negative, so I change the symbol and it becomes greater than or equal to negative 12. Close circle because it can be equal to it. Greater than goes to the right. Number 8, divide both sides by negative 2. When that's negative, we switch the symbol to the opposite. So G is greater than negative 5. Open circle, going to the right. So let me pause this and see if I can get up another screen, and explain to you why we switched that symbol. Alright, let me try and show you why we need to do that. Let's say I have 2 is greater than 1. That's a true statement. If I do the same thing to both sides, it still should be a true statement. So if I add 3 to both sides, I get 5 is greater than 4. That's true. So adding keeps it true. Let's say I subtract 6 on both sides. Negative 1 is greater than negative 2. That's still true. So subtracting will keep this true. Let's say I multiply by 2 on both sides. I get negative 2 is greater than negative 4. Still true. So if I multiply by a positive number, it still keeps it true. Now let's say we multiply this by negative 1. I get positive 2 and I get positive 4. It's no longer true. 2 is not greater than 4. So in order to keep it true, I need to flip the symbol around. So if you notice, right here, it was greater than, and when I did this here, I had to flip the symbol to the opposite to keep it true. So anytime I multiply or divide by a negative number, which I did right here, negative 1, I need to flip the symbol around to keep it true.